My name is Arun, and I'm a solution architect manager at AWS. I'm joined by Dan, who's on my team. Initially, I asked Dan to do this presentation, but he said, would you ever trust me if I went and did the presentation yourself? I said, no. So he's like, OK, let's do it together. And then we started, if I'm coming on stage, how many of you have heard the term vibe coding? That's a jargon right now that's running. I'm going to do something new, which is vibe presenting. This is a presentation that has been created in the last 24 to 48 hours, and I'm not kidding about that. So I put in the abstract into Claude Sonnet 3.7, and I asked it to generate a title for you. And it said, adaptive issue management through open source using domain-specific LLMs. I asked it to simplify it. It said, AI-augmented open source issue triage management. I asked it to simplify it even further. It said, AI agent-driven issue management. And that's the original title which I had given to my talk. Now, there's a couple of disclaimers that I would like to add. These views are solely our own and do not represent our employers. And no LLMs were harmed during the making of this presentation. Right? So, as open source projects scale, what are the common problems that one might anticipate or see? These numbers are from VS Code, which is a popular open source project. And there are 31K forks of VS Code. And then there are more than 3K contributors to VS Code. But I'm really interested in the center portion of the slide, right? It has 8K issues, and it's trending upwards, right? 8,890 to be perfect. That's the data to impress your friend, right? But if you have a project that has these many growing amount of issues, how does one keep up in maintaining the project? As project maintainers, this is the biggest nightmare that one can have. And the problem is same throughout popular open source projects. You can see that the data in Flutter, React Native, PyTorch, any other open source project that you see, based on Octover's report, majority of the developers outside the organization where the project is maintained actually contribute by either creating an issue or commenting on an issue, or like some people like me who come and react to a specific comment on an issue, right? Now, as maintainers, we have a specific triage workflow that we use, right? A new issue comes in, and typically, we spend about 5 to 10 minutes understanding what the customer is trying to do. And then, what we do is we try to reproduce the issue in our local environment. And hoping that things are reproducible, we categorize that either as a bug or a feature request and have an SME from the maintainer community come and fix that for us. And if we need further clarification on the problem statement, then we usually go back and ask the customer for clarification questions, which usually takes up about 2 to 5 days. And eventually, we write the final triage report, and then we come up with a response to customers on GitHub. Now, Dan and I maintain projects within AWS open source. We work on a couple of projects, Amplify and CDK, and we eventually modified the entire triaging process from this workflow to a newer workflow that Dan is going to talk about.
All right, thanks, Arun. Let me see. OK, so with that existing workflow that Arun just described, it works for the most part, right? We're able to, respond to issues, but it does start bubbling up some issues that were evident to us. Really focused on frustration. So, for example, it might take a couple of days to really get to a solution, and so customers might get frustrated that, especially a high impacting problem is not getting addressed in time. There might be scaling problems where, because of the large number of issues that are occurring, we need to account for, hey, how do we, do we need to get more people? Is that really the right approach? Is it scalable? That doesn't really work perfectly, as well as engineers and folks who are working on resolving these issues, and having to, spend time investigating, working on issues, potentially even spending more time on an issue that's not as high priority as an existing or a new issue that comes in later. So one of the solutions that we first started out with was automatic sentiment analysis. So essentially, a breakdown of this: as issues come in, we feed it through an AI-powered system machine, and that allows us to say, hey, this is a highly negative sentiment issue, and essentially escalated. And so that helped us in prioritizing, so addressing high impacting issues that customers are raising faster, and allows us to focus on the right issues. It also helps, tied to that, helps engineers address and focus those high important issues. With addition to, with this new system, we don't need to have a dedicated person spending time with prioritization as well, or to at least meet the demands of new issues. So this is a screenshot. It's actually a live screenshot of the system that we actually do use today, and it just kind of highlights some of the, the view that you get by default. And so from this system, our goal was to essentially help with, the frustrations, the customer frustrations with, negative customer sentiment. But beyond that, we did start getting some benefits that, we started working towards, such as, it gives us feedback on what actually is working based on positive context, as well as, being able to integrate outside of GitHub as well, and be able to get historical context, which was actually pretty interesting because, for example, if the team releases a feature, a major release feature, for example, and we're able to track a period after that release, was there an increase in negative sentiment issues opened in the repo, or positive otherwise? So that helped us in addressing mainly the frustrated customers. But we also started seeing an opportunity to go beyond that, to help, especially with frustrated engineers who are spending more time on these issues. And so in a more recent addition to this feature, we took advantage of MCPs, which is the latest popular craze, which is essentially sort of new. And so what's happened with this feature now, as engineers are working in addressing these GitHub issues, they leverage Claude through MPCs to essentially summarize the issue, highlight anything that needs to be highlighted without spending a lot of time, and also summarize what a fix potentially could be before we respond. And obviously, we're not allowing this to go rogue, do it on its own. We do introduce a human reviewer before we publish and respond to the issue. And so what this has done, the benefit of this, has also tremendously reduced the amount of time that we spend triaging an issue.
So how did the new triage workflow look like? Once a new issue comes in, Claude does the analysis for us, which takes about like 5 minutes. And then it picks up the source code and analyzes the source code, which approximately takes 1 minute. And I promise that I'm not lying through the numbers on the slide. We have a human in the loop to review and validate the response before we send the response out to the customer. So the total triage time, as Dan mentioned, right, was reduced from over 50 minutes to 60 minutes per issue to 5 to 10 minutes per issue, right? And we actually had a success where a regression was caught in under 2 minutes. And you can actually see that how client actually brought the task that was at hand to analyze and triage the issue. And we immediately responded to the customer in less than 5 to 10 minutes, confirming the regression. And the fix was released in less than 24 hours. Right? So the goal of our presentation was to make sure that we bring the power of agentic AI and MCPs. And rather than bore you all with the implementation details, we wanted to focus on the actual success and the metrics that we use to capture the success. And because I mentioned this was why presenting, I had an empty slide which I forgot to remove. Thanks, everyone.